Properties of covalent substances 5.5. A small number of nonmetals held together by covalent bonds is called a molecule. Substances made up of molecules are called molecular substances. Molecules are held together by strong covalent bonds, but between the molecules there are only very weak attractive forces holding them together. These are the intermolecular bonds. For this reason, molecules are easily separated from each other, so have low melting and boiling points. Many molecules are liquids or even gases at room temperature, about 20 degrees centigrade. Water is a molecular substance with a low melting and boiling point. When water boils, it is the weak intermolecular bonds, the forces between the molecules, that are broken. The strong intermolecular bonds, the internal covalent bonds holding the molecule together, remain unbroken. Molecular substances are usually gases or liquids at room temperature with low melting and boiling points. They are poor conductors of electricity. They are usually not very soluble in water, but there are a few exceptions, for example sugar. As they are not made up of ions, they do not conduct electricity in solution. There is another type of substance that is made up of nonmetals held together by covalent bonds, but these are not molecules. They are the giant covalent substances. Giant covalent substances are made up of millions and millions of atoms held together by covalent bonds. Why are they not molecules? The clue here is the millions and millions. Remember, a molecule is a small number of atoms held together by covalent bonds. Diamond is a perfect example of a giant covalent substance. It is made up of just carbon atoms. Every carbon atom in diamond is held together by 4 strong covalent bonds. For diamond to melt, all of these bonds must be broken. This requires a lot of energy, resulting in diamond having a very high melting point of 3,550 degrees centigrade. As each carbon atom is bonded to another 4 carbon atoms, diamond is very strong and very hard. Actually, carbon is the hardest natural material on Earth, with a maximum value of 10 on the hardness scale. Substances made up of the same element but found in 2 different natural states are called allotropes. Carbon has 2 allotropes, diamond and graphite. Diamond, clear, hard and very valuable. Graphite, grey-black, soft and slippery, cheap and a good conductor of electricity. Like diamond, graphite is made up of carbon atoms, but each carbon atom is only bonded to 3 other carbon atoms. This gives graphite a flat ringed structure. Millions of these flat rings lie on top of each other, creating layers which can easily slide over one another. Our pencils leave a layer of graphite on paper as we write. With only 3 bonds, each carbon atom in graphite has a non-bonded electron. This electron is free to move from carbon atom to carbon atom. It is this free electron that gives graphite its ability to conduct electricity. Giant covalent substances have high melting and boiling points. They are very hard, except graphite, poor conductors of electricity, again except graphite, and are insoluble in water. In the photo here we can see one of the unusual properties of graphite, its ability to conduct electricity. Another giant covalent substance worth mentioning is silicon dioxide, SiO2. It is better known as sand or quartz. Its simple formula is deceiving as it is not a molecule but a giant covalent substance. Each silicon atom is attached to 4 oxygen atoms. The oxygen atoms are attached to more silicon atoms. Its formula, SiO2, is the ratio of silicon atoms to oxygen atoms found in the structure. Of course, there are billions and billions of silicon and oxygen atoms in even the smallest grain of sand or quartz. You should now complete the multiple choice test, Giant Covalent Substances 5.5. As usual, you are free to use your copy of the periodic table of the elements.